Hey there. So this video is about solution of this specific assignment. So those who have studied Verilog and test benches, they should not jump to the solution part of it. They should just read this assignment and try this out. And if they struggle in it, then they can look into the next part of the video where we are discussing the solution. Otherwise, they should just pause here and look at the assignment and try to solve it themselves. Or even if when they have solved it, they can also just get back to the next part of it where they can compare the solution with my solution that I'll be discussing here. So now I'm coming to the solution. So if you want to do it yourself, pause it right here. Okay, so the question is that this is a design of reg file. So we have four registers, one demultiplexer controlling the enable signal of each registers, and a data in that has been broadcasted to all registers, and a mux that is selecting which register to forward at the data outline. So you are asked to write regfile.d and Verilog code that implements this design. So you don't have to design it; you just have to implement it. Design is already there, and then you have to write a test bench that writes a few values to registers and then reads it back in a specific order. So I'll start with the first part, that is writing regfile.p. So I've already shared the Verilog slides. So if you know that, then first you have to create a file regfile.v, and from there you write the port list. So here is my regfile.v. So if I just so you can see that these are the port lists: address, write, data in, data out, and clock and reset, just like in the diagram. So in the diagram we haven't shown clock and reset, but if there are registers, then there is underlying assumption that they are running on a clock and there's a reset signal. Rest of the signals are same. So next thing is that we just write one by one all these blocks. So let's say if I start from left, this is a demux. So if I go to the Verilog slides that I've already shared, so uh, so from where here we can see that a demux is written in this way. So we can follow the same way here. So we can just have an always and static statement, and then case, select line, and here we have the code for demux. So if we look at the diagram, uh, we have to have four write enables for each registers, and there is one write coming in. So we have declared write 0, write 1, write 2, and write 3 as regis, and we have made a case statement in which we assign all of them at once, and we assign if the address is 0, write 0 should be 1, so we have assigned 1 to write 0 and 0 to the rest, and if it is 1, then write 1 will be 1 while rest of them will be 0, and so on. So this is how we write the code of demux. So if you have already gone through the video of Verilog coding, then you should know that. So next part is writing registers. So again, if I go to the Verilog slides, this is how we write code for a register. And if there is an enable, then we write else if and then put an enable there. So in our case, there is an enable signal. So this is the code of registers, and each write signal in this code from this demux is going to act as a as, as an enable of every register, and data in will be the data in of every register. So here is how you write register, always at positive clock. If reset, reg 0 is 0, reg 1, reg 2, reg 3 all are the same. Just what changes is that if write 0 is 1, then data in will be written in reg 0. If write 1 is 1, data in will be written in reg 1, and so on. So this is how we write code for registers. Then we have a mux here. Again, mux is written as a case statement. If we go to the Verilog slides, it's right there. We have discussed how we write a code for a mux. So similarly here we have written code for a mux, always at static, case, address, and that out is selected based on address. If it is 0, then reg 0 is forwarded. If it is 1, reg 1 is forwarded, just like it's shown in the diagram here. So reg 0, 1, 2, and 3 should be tried based on address. So since we have written all the components, so first part is done. Next part is to write a test bench to test this thing. And so what we do in the test bench is that we copy this thing and we paste it in the test bench file. Test bench file it doesn't have any input and output. We just declare the inputs generally as regs and outputs as wires. And then we write this code for creating a clock. This has been covered in the previous lectures. And if we want to have a dump file to view waveform, then we write code for that. And what has been asked here is to write test bench such that it implements write 4 different numbers to register to 0 to 3 in 4 consecutive cycles. So here I have written code. Uh, First of all, I have just assigned inputs other than clock, because clock is assigned here. Rest of the inputs I have assigned them to 0 at the start, and then these 4 lines are just resetting our circuit and just passing 10 clock cycles. Now the next part is this one. Write 4 different numbers in 4 consecutive cycles. So this is a requirement here that we want to write 4 values in 4 consecutive cycles. So here what I have done is this is just a display to print something on console. And what I have done is that I have created a for loop, and just like in C, we can have a for loop. I have declared I as an integer. So in Verilog, we don't write int, but we write integer, complete integer, and we don't have I plus plus. We have to write I is equal to I plus 1. So rest of the things are pretty much similar. So here what I have done is that I have assigned address as I. So I is going from 0 to 3. So in every cycle I will be 0. First in first cycle it will be 0, then 1, then 2, then 3. Right is 1 in all cycles. And I had to write any value. So I have used just multiplied I with 16 and written that in the reg file. You can use any value as per assignment. There was no restriction here. You can actually use $random here if you want to really select a random value. And then we spend a POSIX clock so that this is executed, because every transaction is executed on a POSIX clock. After that, in the next iteration again, we just have a delay of 1, and then we assign things, and then we delay for a clock cycle and so on. In the end, when we have written all the 4 values, we just set right to 0 and rest to 0 and return to 0. So next part is that we want to wait for 10 cycles. So for 10 cycles, we just repeat 10 at POSIX clock, and that's it. And after that, we want to read values. So next part is that we want to read values in 4 consecutive cycles. So this is the same loop, just that I don't have to assign write or data in. I just need to change the address. So I am just changing the address, and after that, I am just delaying for 1 cycle, 1 tick, not cycle, because cycle is 10 ticks. So I am just delaying for 1 tick, and then I have this condition that if data does not match with the value that I was expecting, I into 16, then I'll raise a flag. So right now I have commented this out just because I want to display it every time. So right now there will be a false flag that it is mismatch even if it is correct, but I want to see the values. So that's why I've just commented it, but after that I'll just uncomment this part. Uh, and then third thing is that next part was write 4 more values which are separate from part A with 5 cycle gap between writes. So this is again a loop with a similar loop, but in between I just spend 5 idle cycles. So after POSIX clock, I repeat 4 cycles with writing nothing. Similarly, next part is to read 5 values, and here I have changed the value that I am writing. So where is it? Is instead of I into 16, I am using I into 32, and Similarly, this is the code reading those values, and again I've just added delay for 5 cycles just as per question. And again I have commented this if so that I just can see the values, all the values. So now I'm going to run it. So here is the code. So I'll just uh, open it in a PowerShell window, and I'll just compile it. Let's say so I'm just asking iVerilog to compile our Verilog files and generate an output as tbreg file. So it has generated it. Now I want to run it. So to run it, I again use PVP and just give the file. So now you can see that although this is mistakenly written as mismatch because I have disabled the if statement, but we have in hexadecimal 0, 10, 20, 30 and 0, 20, 40, 16. Hexadecimal 10 is 16 and 20 is 32 and 30 is the next multiple. And similarly here 20 is 32 and 40 is 64 and so on. So these values are correct if I want to actually now enable the if statement, so so that it's only displayed if there is error. Then I can just uncomment those parts and recompile it, rerun it, and you can see that there is no error message, and I've written in to the regis and read back. Uh, you can also view the wave file. So because we generated a sorry UTK wave, I just use the wrong spellings, and you can see the values being written in the regis here. So reg 0 takes value 10, 20 and 30, and later on 20, 40 and 50, and you can actually verify this. So I'll be sharing the code with you, and I'll put the link in the description for both these codes as well as the Verilog file.